Okay, maybe if you could
Yes, we
leave
can.
some thumbs up in the chats. Okay, then that's good. So I'm Moses Winichi Al Hassan. I'm a backend developer at FormPlus currently. I mainly specialize with Python-based stacks, so Django and Flask, and also a bit of machine learning and the likes. So also, yeah, I'm from Ghana, and it's nice to meet you all. Okay. So today's lesson, can you let me know when you can see my screen? So I'll share my screen right now. A minute. Um, can you see my screen? Okay. I'm trying to get through the chats. Okay. So kindly feel free to unmute your mic and talk if you can. And if you feel like it, I don't mind. So today we'll be going through the HTTP verbs with Postman. Those are the get, post, put, patch, and delete. And we're going through them in this. So let me push this here so it's less distracting. Okay. So we'll be going through it in this format. We'll first get a brief understanding of what servers are, how requests look like, and just a rough idea of them. And then we move to the HTTP verbs and also Postman. So kindly give me a minute to set up. I'd like to open the chats down here. Okay. So servers, what are servers? First, I'd like to clarify. I was informed you guys have all gone through REST APIs and the basis of the RESTful API technology. Can you guys confirm that? Or maybe if anyone would like to say a bit, it's not so about REST APIs, maybe what you guys have gotten to, or you understand so far. Feel free to unmute your mics if you like.
Okay, so they can't unmute, but if they have anything to say, they raise their hand and I will unmute the person.
Okay. So if anyone is up for it, if not, well, then we can move ahead. Please don't be shy. I don't bite. Okay. So we're starting with what are web servers. So per the Google definition, they are just programs which manage access to centralized resources in a network. But simply put, they are just software that's specially designed, or okay, we can't really call them software per se, because sometimes they can also be an actual computer. So they are actual computers or softwares that are specially designed to accept incoming requests. And I know most of us go to YouTube, so I use this as an example. So when you visit somewhere like YouTube, we are making a request to the YouTube web service, and that's how the whole two-way handshake is like initiated. So the client initiates a request to the server, and the server has the software to understand and process your request. So moving on. If you have any questions during the whole session, kindly raise your hand so we shall meet you. So moving to request. So just to get a brief or like a rough idea of how the request looks like to a server, it comes in something like this. So you visit youtube.com, it sends a request to the server, and the request looks something like this. It's a get request, sending it to the path, the slash path, which we would call the root, is known as the root. And it's using the HTTP 1.1 protocol. I'm not sure whether these days they are moving to the 2.2 protocol yet. I would have to confirm later, but yeah, mostly it's the 1.1 protocol. And the host is youtube.com. So sometimes you visit the site and you don't find the slash. The Google Chrome does that a lot, but just be mindful, the slash is always going to be there. So this is just breaking it down. The verb is get, the route, the protocol, and the host. So moving to the HTTP verbs. At this point, I'm going to assume you've had some interaction with the HTTP verbs, especially the most common ones, which is get and post. Okay. Is anyone sending something in the chats? No. Okay. Don't be shy. Feel free to talk and text, send me messages as well in the chats. Okay. So the get verb, and with the get verb is just mainly to retrieve resources. So when you have your REST API, you have the whole idea of the RESTful API is to handle resources in a stateless manner. So it's to process them in a stateless manner. And with this, with a GET request, you are requesting for a resource. Mind you, resource is just data, but that's like the fancy term we use to make it seem all. But yeah, it's just data. So when I use resource or data here, I mean the same thing. The GET request mainly is to retrieve data from the servers. But you'd also find something like Google, Google, the search engine. It's also a GET request we make, but we make it with certain parameters, things that would look like, oh yeah, someone has mentioned CRUD operations. Yes, the basic CRUD, that's the create, read, update, delete. Yes. So with sites like Google and also maybe other APIs where you have GET requests that also not just retrieve information for you, but also receive information. That's what we would call the query parameters. We'll get to that later on in the demonstration part. So this is just an example where we have a GET request to the top universe domain. We are trying to access the students and we want the first student in the database. So yeah. So moving to the second one, and let's see the most popular ones, that's the post. It receives data and processes it. Some people also like to define it as it's being a way to create new or add new resources. And well, it's all based on how they are working with the service or instances. That's what maybe skew their bias into which definition they would use. But generally, with RESTful APIs, we are dealing with resources. So when we talk about post request, we are trying to find ways of generating this thing, data or resources. And we would receive from the user, and we are expected to create or generate a resource out of what we are receiving from the user. A typical example would be something like this, where we have a post request to the top universe students, route or endpoint with a create. The payload would look something like this. So with get request, we also include something that's referred to as a payload. When I say we, I just mean developers or backend engineers mainly. Um, so the payload, you include a payload which is in the form of JSON. And yeah, this is just a rough example, something like the name and the course. And we send that to the endpoint. And what would be expected in a typical post request would be this JSON we are passing to the endpoint, which is the top uni students create, is going to be processed into an object of some kind and saved in a database. And that's the main idea of the post. We want to use whatever we are receiving from the clients to generate or to create new resources on our side. So moving on to the put. Put is quite an interesting one. So with the crowd operations, yes, someone has mentioned it, the index. What's do you have an idea of the put operation? Just to find out, you could reply in the chat or just raise. Okay. Yes, that's update. Absolutely. Okay, that's nice. So yes, so it's used to update all properties of an existing resource. And this usually has some kind of friction with the next one we'll be seeing, which is the patch. Because the main idea around the put operation is to update the entirety of a resource. Say, for example, you have students in a class. A put operation would be replacing one student for another. That's maybe you have 10 students in a class, you want to take away the 10 students and replace that student with another student. Yes, yes. Yeah, they are kind of similar. They're kind of similar. We'll get to the main difference in a bit. But some people also use the put method to, when I say method, I just mean the function or the HTTP verb. So some people also use a put method to ensure a resource or an entity exists. In a sense that if you have, yeah, good. I see you guys way ahead. That's lovely. Okay, so the puts usually people double it as a way of checking the database, because what it does is that when you use a put operation or a put method, it first checks whether the entity exists or the resource exists. So for example, you are assuming you have 10 students in a room, but because we are dealing with RESTful APIs, it doesn't know what is going on. Everything is in a dead state or in a stateless form. And you are going into the class, you want to switch up the 10th student. Maybe it's a very short person, you want a very tall person in the 10th row, or maybe it's a very tall person, you rather want a short person in that point. When you go there, you are going under the assumption that the 10th student exists. And because it's REST, there's no way of confirming except just going and checking from the database or from the resource. So usually put, we would use it we call it put enabling duplication. So when you enable that and you ask to update the entirety of a resource, once it doesn't exist, it's going to create the resource for you. So it will double up as a post operation for you. And that's a very lovely thing. Some people take advantage of this to the extreme. So an example would be something like this. You have your original resource, which is just Misty, and it calls backend for proofs. You run a put operation and you pass in the payload happy Misty, and it calls maybe I'm certainly a front-end engineer. Um, that's mainly the main idea around put operation. So you just make a call to an entity or a resource you are assuming under the impression that it exists. And with that, it would update it if it exists. If it does not exist and you have duplication enabled, then it would create it for you. Then we move to the patch. So the patch operation is basically the exact same operation or the same verb as the put. The only slight variation comes in with the patch. You want to update a specific parameter of the resource you are targeting. So for an example, you have 10 students in a class. You want to switch up the 10 students in the class, but you are not trying to change the whole student for someone else or for a different thing. You want to maybe change the bag they use or the bag they bring to class. So you'd run a patch operation. You are patching up something or an aspect of the resource. So you are patching up a parameter of the resource. So you have an entity with 10 parameters and there is an array of maybe 10 of them. You just want to change the fourth or the fifth parameter and not the entire one like you'd find in put. Some bad practices we can avoid is using put to enable the features of patch. There are ways you can enable that, but that would be a bad practice and you'd get into some potholes later on in the development. So yeah, that's the main difference between put and patch. From my understanding, I think when they either patch or put, one of them came before the other and they didn't want to mainly develop the next method, but there was some contention along the lines and they made that's the main difference between the two. Just the updating of specific parameters and the updating of the entire resource or data. So we have an example like this, where we have Misty, we have the course, and when we run the patch operation, we are passing in this whole thing, but please don't let the example confuse you. This wouldn't be the best example, but say you can pass in just the name for a patch operation. Pass in just the name and you would have only that updated. So here you'd have only the name updated, or you can pass just the course. So you can have an endpoint that just patches up only the course parameter for the object. So only this section changes, but the entire object, the entire resource you have is going to remain intact. It's not going to change. Moving on to the delete. Yes, this is the most interesting one, and this is what. Okay, someone was asking patch is partially update, right? Yes. So yes, it is. With patch, you are updating just a section and not the entire part. That's why we call it a patching up. With the delete operation, delete, there are some concepts around it. Mainly, it's just as the name says or as the verb says, you are deleting. Okay. Yes, yes. So we use the resource ID. So with everything in life, we usually find it easier working with it if we have something to identify it. So human beings have names, TVs have model numbers, phones have their phone names or the phone modules and the year they were designed. We always use certain things to differentiate them. So it's easier to manage or interact with such things. There's not much difference when it comes to the case of RESTful APIs. So we have lots and lots, thousands, and in some cases millions and billions of resources in our databases. We would need a very easy way of identifying which ones we want to deal with or we want to process. And the best way to do that is usually the IDs. The IDs comes with certain complications, but that's the topic of for another day. So yes, it's easier to identify them with the resource IDs. So with delete, ID equal 1. Yes, yes. So thanks for pointing that out. So patch, yes, I used the 1. So the 1 here I made reference to in the request is the ID of the resource I'm trying to make the effect on. So when I run this, it's going to go through the students with this ID. And you see that in the demo we'll be having shortly. It's going to run through the student with just this ID and run that operation, the verb on it, the put or the patch, or it gets if we are getting a specific record. So yes, nice button. So with the delete, there are two concepts mainly people follow. That's the soft delete and the hard delete. I just wanted to bring that up because it's usually a pain point for most people who start developing REST APIs, make it very big, then they realize they need to have a soft and a hard delete policy in place. Yeah. Oh, no worries. Please ask questions if you like. The main idea is to get understanding. So if you just need that little explanation to get the understanding, feel free to ask. That's perfectly okay. So yes, people use hard delete and soft delete, and it's good to get introduced to it right now. And yes, thank you for the question. I'll get into the differences right now. So when you want to delete resources, so I'll give a background before we get to why they exist and the differences between them. Most big firms and also big programs, we can use programs like WhatsApp, Facebook and the likes, have people who come to audit them. When you have auditors coming, there are some policies you need to follow when you want even your app to hold certain sensitive information. And removing information at will, completely purging it from the system, is the worst thing you can do. Because say, for example, someone comes to make a request to take $1 billion from your system. You are a payment gateway. So the person comes to make take $1 billion from your system. You realize that it's a mistake, but the person opted to remove his transactions or his or her transactions earlier. There is no way on earth you are going to find when they made a transaction, who made a transaction, how they made a transaction, or with what credentials. You are in trouble. When auditors come, they are going to say, where did the money go? And you're going to be left like found wanting. And that's when the soft delete, the concept for soft delete came about. So you realize when you tell Facebook or Google or Twitter or any of the social media platforms, when you try to delete your account, they tell you that you can recover your account within a period of 3 months, or I think some even keep it up to 5 or 6 months before you cannot recover your account anymore. That's before they actually run a hard delete. So the soft delete doesn't change actually delete the resource. It patches it up. So some people you see, even though they have a delete button, when you check the network operations running, you see that when you press a delete button, what it does is it calls the patch operation, the patch method, and it changes just one field. We'd call it a flag at this point. It changes just that one field. It flips it from maybe true or false, and we can call that field deleted. So you run the patch method, you run the delete. The it doesn't actually call delete, it calls maybe a patch, and the patch just updates the deleted is deleted flag to maybe true. So for the front end logic for anyone, they would see that their account has been deleted, but it's not actually deleted. It's being saved in a separate place for auditors to come and get their logs and their histories they need to do their auditing, and also other people. The hard delete, that's usually going to be run in a background or maybe some cron job that would run maybe months or some months or even a year away. I know Microsoft does keep your data for up to 2 years or so, a year and a half, I think, before they would delete it completely from the database. And that's what's brought about some of these privacy concerns and the likes, because most people keep it, like to keep your data for a long time. Yes, it's more like a recycle bin. But the thing is, most non-developers don't understand that by law they are even meant to keep it. So there's usually this anger about it that, oh, they are hiding, they are using our data, they are keeping it and the likes. They are forced, or sometimes they are mandated by law to keep your data, to follow some compliances. But if they double up to sell it to other people to make a profit from it, fine. they are doing you bad. But most times most developers don't have a way around that. You'd have to keep the information. So soft delete is the safe bet if your application will be growing up, like will be growing bigger to host maybe big to an extent that people would have to audit you seriously. And hard delete is what you would want to do later on, or you can put a background task to do it in maybe some months' time after the user has requested for their information to be deleted. An example of the delete is just passing the delete, given the ID of the record you want to delete, and it removes it. This also gives us the response. So all the HTTP verbs, these methods, they all give back response codes. And the response codes are just feedback to let you know the success status of the request. So if you make a request, you want to add an extra student to a class or to a list of students. If it's successful, you would like to know. If it's not successful, the response code, excuse me, the response code would prompt you, and maybe you would know that at this point that I should initiate a retry policy or the likes. See whether I've answered all the questions. I hope I have answered the question of the difference between soft and hard delete. If there's anything you don't get, please feel free to ask. I'll go through that again. And yes. So soft delete just enables a recycle bin for you. So moving on to Postman. But first, I'll run you through the code so we know what is happening. Just to make things fast, because we don't have much time, I used Flask to design a sketch back end to just make us have a feel of the operations. The slides and also the code will be shared if you are interested in that later on. So I just created an app instance, used JSON or a dictionary, Python dictionary. Kindly let me know if you are conversant with Python. If not, I could explain this much better. Are all of you okay with Python, the Python programming language? Okay, I'm not getting much responses, so I would assume. Okay, that's fine. I apologize for using this. I feel JavaScript is a more popular language than Python, so that would have been best to use, but with the time constraints, it just seemed right to go with Python. Okay. I'll go through it. So what I'm doing here is creating an app instance. You don't need to bother yourself about this. You can just ignore it. The main part starts from here. So we don't have a database maybe a Postgres, SQL, an Oracle, MySQL database, MongoDB, and the likes. We don't have one instance of it. It would have been just overkill to deploy an instance for it right now. But would use a Python dictionary, which is what but are all of you okay with JavaScript? I could just translate whatever I'm doing into the JavaScript equivalent and let you, so it's maybe it creates a better understanding. Okay. Okay. So a little bit between the languages. Okay. So I'll use JavaScript as the reference between the things I'm doing here in Python. And if you have any questions, please quickly prompt me or put it in the chat and I'll go over it. I'd like you guys to all understand this clearly. So in JavaScript, you'd call this an object. So this is just a JavaScript object or JSON, but the Python version of it. We call it, Python developers would call it a dictionary. So I'm creating an object with integer keys and another object for their values. So they each have keys, which is 1, 2, 3, 4, and each of the keys has a whole object as their values. And the reason why I did this was to simulate a database and also to make it easy for us to run the request we'll be having down here. So what's happening is each ID is linked to a student object, and the student object is just the ID is duplicated here for convenience, the name, the course. So these are the properties or the props of the object I've just created here. If you have any questions, we could just go through it. I could create a little object here and show you an equivalent. I think this would be more familiar to you. Something like this. So you'd have something looking more like this on a regular with GS. Let's just have this. So mostly the JSON will look like this, but what I just did was I took these ones. I took the whole of this, created another object, gave it an integer for its key, and just filled it up with these values with this object. So the routes. So when you deal with REST APIs, the idea is you have an entry point to the API or to your APIs are just application programming interfaces. So you have a entry point to that interface. And we usually start with the root path, which is the slash. So when you go to google.com, you are usually visiting the slash route of something because you haven't yet added slash anything. And this is just an intro. So the method name you use, this is a function, a Python function. So we are just telling it that this is our app. We want you to take any request, HTTP request, whether it's a get, post, put, take that and return this string, which is hello folks from Top Universe. Well, hello. That's the first one. So this is just a basic one. And what the second one is doing here is we want to retrieve all the students in our database. We are assuming we have a database right now. So we are running JSONify on it. This is the equivalent of what you'd have in JavaScript, which is going to be JSON.stringify, or that's the opposite of that. Yeah. So we are just converting whatever we have to JSON instead of the other way around. So we are JSONifying the top universe DB, which is what we have here. Yes, exactly. So the dictionary is our database currently. So we are going to work with it like it is our database. But because we don't have a database, it's going to reset anytime we restart the application. So this would be our starting point. And none of our changes will be permanent after we restart the application. So yes, the dictionary is our database. So we want, when we run the get request, to the endpoint top uni students dot int. Okay, welcome. So when we hit this endpoint, or when we make a request to this endpoint, we would want to retrieve the database, our database, which is this. And what that's going to do currently is, when you do not include the verb you want to filter by, it's going to by default make a get request. And also all our browsers by default make get request. When you visit any web page on the browser, you are just making a get request to that web page or that server, and you are going to get whatever resource it brings back to you, mostly, which is that's going to be an HTML page. Then you see all your fancy stuff. So the get, so here we are just getting a specific record. So I've indicated that the type of the parameter, which we are calling student ID here, is going to be an integer. So we would have our normal endpoint here, the root and the other part, then slash the ID. And it's going to take the ID here in this function. So whatever is being called here should have the same name as what we are passing in the URL. And we are going to take whatever is being passed there. We are going to search through our database and get that element. So you realize I used the integers for the keys of this dictionary or this object, and that's why I did that. So it's easy to identify whichever one it is. If you use an array, it might seem simple, but an array is very slow in the long run. It's going to run through all the elements in it just to find one. And if the element is at the very last point, you are going to go through all the 4 elements before you get to it. So here we are just getting a specific entity. If there are any misunderstandings or confusions, you just kindly point it out and I'll get that. If I'm also moving too fast, please let me know, or too slow, let me know so I move faster. So yes, so here you'd see that the difference here is that we are specifying the route, but we're also telling the method we want to accept. We're letting them know that we want post requests only on this route, and everything else should be rejected. So you'd get a 400 response. That's telling you are making a bad request. If you make an HTTP request that doesn't have post in it. Let me check my time. So yes, I'm running out of time. So let me blaze through this a bit. So with the post request, what we are doing is we want the JSON the person is making, like sending to the request, because we know post request retrieves data and receives data rather, sorry. So post request receives data. So it's going to receive a JSON, and that's what we are converting into a Python dictionary. So this method just converts the JSON to a Python dictionary. And then we want to create a new ID because it's a post. Okay, nice question. So the main difference between Python and Django and Flask is that Flask is a lightweight framework, but Django is a full-fledged framework. So what I mean by that is Flask gives you the skeleton of the framework, the tools you need to build and improve on your application, be it the Django REST framework, which is geared towards just RESTful APIs, and the Django itself, which is the mother one, which can also do websites, can be used to build web apps and the likes. Flask is the bare minimum. Oh, this is an interesting question. None of them is the best. I'll be honest, I feel 3 years ago, I was stuck here trying to find which one is the best and learn that's the fastest. But it's a very, very steep hole to enter. It's a very sticky thing. I would say understand what each of them does very well and get the specifications of whichever project you are to work on. And oh goodness, people are making fun of Laravel. So you'd get the project you are to work on, understand the specifications, and then pick which framework to work with. I used to work with Django for over a year, but with the next project I was doing this year, I realized sometimes the job you are working on would dictate which framework you should use. But if you have the freedom, you should have that consciousness to decide. The application I'm building is not going to be too heavy or dependent on databases. So why don't I use Flask, which is very lightweight? The application might be fast. Or maybe if it's a very payment services or tight security and has to do with serious integrations, third-party integrations, you might want to go with Django because Django has almost everything designed just for that. And it uses the MVC pattern, which is very, very good. It's very opinionated, but it's also very robust. And that's why most big organizations still rely on Django. But recently, there's been a shift to Flask because Flask has introduced some very, very powerful features as well. Moving on. So please let's not make fun at Laravel. It's quite good these days. So with the post method, we are just creating, we are just receiving the JSON they are giving us. That's being sent to the endpoint. We are updating the database's indexes. So we will just count these, get the last number, and we would update it by 1. So that's what I'm doing here. So length is the equivalent of .length in JavaScript. Then we create a new record. So we create a new object out of that. We give it a new ID, which is what we created here. We are passing from the request that has been passed to us. We are going to take the name parameter passed into it and put that here. And we're taking a cost parameter and using that to create the new record. Then we would update the database with the new record we have at the specified ID we now have and return that to our user as JSON. And that's going to go with the status code of 201, which is created. Usually you'd like your post method to return an HTTP status response of 201. That's if you are creating an object or creating a new resource with that post endpoint. So Flask handles this nicely for us. And the put, you see put here, we are taking the JSON status code. Yeah. Oh, okay. Let me just explain a bit into status codes. So when you have a request, any of the HTTP verbs, the server takes it. Just like any communication you have in real life, maybe with a person. When I call your name, you respond with yes, or I'm listening, or something like that. The server is also to respond back to the client, the one making the request, and tells them your request was successfully served. Just like when you go to a bar or maybe a fancy restaurant, the waiter comes, you tell them you want maybe a large bowl of jollof rice. and they're like, okay, we'll be processing it. So they go back, they tell the server who is going to be the chef to cook the meal, the jollof rice for you. When the server, which in our case is the chef, prepares the jollof rice, the waiter is then to come back to you and tell you your food is ready and bring it to you. That's the same thing happening here. When the post request is done, it cooks the jollof rice. It has prepared, created the entity. It brings it back to you, tells you it is done. And that's what we have here, the 201, which is the status code, telling it that, yes, I am done and it was successful, and gives you, and what I'm doing is I just let it send you whatever it's updated into the database as well. So you know what it has added, what it is done with. The push request would just do the same thing we did here in the post, but what it does is it changes the entity at that specified location. So we give it the ID, it changes the entity to the new one we are providing. And this will be made clearer when we look at the response in Postman. We'll get there shortly. Patch does something similar, but you can see here that patch just takes one entity, which is maybe the name. We want to change only the name. We don't want to change the course, and it returns it. Delete, we are using the hard delete in this case. And you'd see I have some statements here, which maybe you're not familiar with, or maybe you might be familiar with. These are just abort statements. We're telling it that if the user is making a request, that doesn't make sense. This is how you should respond. And you'll be seeing a lot of 404 not found pages. If you've been browsing a lot, you'd find the 404 not found. These are how we create them. We use abort statements. We tell the user that this is the status code. So the 404 is the status code, and each status code has a meaning that the browser understands. So 404, the meaning for that is not found. So you always find 404 not found. And I've decided to include a message just telling them that the student with a specified ID does not exist. That's if they ever pass an ID that's not in our database. So moving on, this is just to a Python syntax to make it know when to run. Try and catch. Yes, exactly. So try and catch for exceptions. So exceptions are more of an exceptional situation, less of just this normal one. So we just use normal ifs for this. But if there are maybe IO operations, maybe you are going to pick files from the file system. The file system has a very high likelihood of failing on you once in maybe a thousand times. So you use a try and a catch. And the tries the method you are doing. If it's a success, it forgets of the catch. But if it's not a success, it catches it and it throws an exception. In the exception, you can also just make it through this abort. The abort is basically an exception. Even if you use the IntelliSense, one way or another, it shows it here, an HTTP exception. So moving on to Postman. Oh goodness, we are down on time, but this should be a success. So with Postman, just to give you a rough idea, you can have your tabs here, a lot of tabs. You can always create new tabs or new requests. Give it things like the URL you want to work on, and you click here, the drop down, you can choose any of the HTTP requests you want. So you realize here there are quite a lot of them. So what I just covered are the primary ones, but there are a lot, and they all have their specific functions. Some I don't even know, of course, I've not really encountered them that much, but yeah, there are other methods. You'd find the params here. You can put them here. You have the authorization. If you are dealing with authentication and authorization, you can put those here, or you can include them in the headers section. That's the HTTP request, usually move with headers. It's like metadata. Do you understand what I mean by metadata, like the concept of metadata? Okay, I don't know whether Okay. Okay. So let me just, okay. Nice, nice, nice. It's nice you all know that metadata, so data describing data. And we have the, okay. So I'll just explain it anyway. Thanks for prompting me. So metadata is data that is used to describe data. So we call it metadata. So you have 10 people carrying 10 bags. The bags each has a tag on them. What's written on the tag is metadata. The bags you are sending is data on its own, it's information or a resource. But what describes the content of that resource, whatever is in the bag, maybe they are carrying 10 bags of gold. They will write a label there, these are 10 bags of 20, 25 carats gold or whatever it's called, and you would know. So in the HTTP request as well, when you are making requests, there are things or metadata that describe the request you are making. And usually the headers is where it's carried. So you'd have headers for like something like authorization. See, he's brought it here. Usually when you're dealing with authentication, authorization, you'd find that here, then you put your token, things like tokens and the likes. You'd also have the body. So this for post request. You can have an empty body. You can have form data. That's if you are dealing with forms. JavaScript, when you build something with React and you're dealing with forms, you usually have pass form data and not JSON, not direct JSON. So you just put a key here. You type a key, maybe in Moses, and the value maybe 1 or 2. So yeah. And you could also have the XWW form URL encoded. This is what you'd want most of the time and not form data. This has really eaten up a lot of people's time, the form data. You'd want this instead because most browsers would rather recognize this and not that. And we would have raw, which is what we are going to use. And we are going to choose a drop down here to JSON. And that's going to tell the Postman that we are sending a post request. So we've chosen a post request from the drop down here. We want it to include a body. The body is going to be of a raw type. Which kind of raw? We want that to be of type JSON. Postman has very handy features. You can document your APIs with Postman. You can have scripts to work on the response you get. Maybe if you go into a sign-in page, you can have a script that would extract the authentication token it gives you. Then all your subsequent requests would use that authentication token. So you don't have to repeat it every time. Most people don't know that, but that's a very handy feature. So moving on to the verbs. So I'll just go back here and run the application. So let me clear this. Python app.py. So I'll be running the Flask application now. I'm running it in a virtual environment here. And you'd see it gives me the URL to access it through. And if I do click on this URL, I would be getting something like this, which is, you see, as I mentioned before, Chrome does not let you does not include a slash when you are just using the root, but it is there. Don't be deceived. And this is just the response for the root page we had earlier. Moving back. So we would have the get request. Yes, like a home page or index. So when you have the home page here, so usually your home page or your index is just here, and you return, instead of returning a string, maybe you can return a file, an HTML file, and that would be the index.html, which is usually your home page. And that's how that is done. That's how it is served to most clients. So here, that was what we hit. And I mentioned before that the browser mainly makes GET requests. So this is a GET request since we haven't included the methods we want to run on it, unlike here. So we got the string, hello folks from Top Universe. How can you return HTML? So you can return files as well. So if I did have a file, I would have opened it with something like path, indicate it. Let me see whether I can just get you an example I have. A minute. This should be handy. So you can have something like this. Yes. Let me share this with you so we don't have to take too much time typing it out. So I copy this. So you'd have something that looks like this. So please ignore the squiggly lines. So you'd have something that looks like this. It opens a file at some temporary location in read mode. Takes it as a file as the alias of f. It reads it, it loads it, loads that data into maybe JSON, and it goes through all the lines of it. So maybe all the records. It takes maybe names if our name. Okay, we're just making a comparison here. We are ignoring all things with the same name, and we are appending. So we are adding to the file. That's mainly what this is doing. But in other requests, you could use the render. So we use something called render, and you render the HTML. So that has methods in the background to handle returning files or byte objects to you. Okay. Sorry. Okay. Sorry. Okay. So if you want to return HTML, you can just use the render method. That's the easiest route to it. We are running out of time, just a minute remaining. So I'll make this quick and we would see how it works. So here we are making a GET request to get the first student. You remember the URL had here as the ID. When we make a request to it, we get the first student in our database, which is this. The course was back end, the ID was 1, and the name is Moses, the same as the ID we have up here. If we use a post method, so these were already just typed by me, but you can always edit it as you like, either management or HR. You can change the course to HR and switch up the name to whatever you like and make a post request to the create endpoint. So we loaded the endpoint here. And if you're wondering where the local host and port 9000 came from, that is the local host and the port I specified in my application that we should access the server through. So we are accessing it because it's running locally. We are accessing it by default on localhost, which is the 127.0.0.1. And we're accessing it through the port 9000. So that's the port I've opened to listen to requests for this application. And it is on debug mode. So when we get errors, we can debug it. We can see the whole stack trace. And when we make the request, we got a return of this. I made this convenient method so we can see all what is in a database and always know what is changing. So you see that Moses, the ID of 1, Moses backend, this is just is returning, or this is the get method that's returning everything in our database. This is the new student we added, who is Chris, has a course or is studying the course HR and has the ID of 5. And then we can go to put. We want to put or we are updating the whole entity with the ID of 1 with this credentials now. When we go back and we look in our whole database, we see that the ID of 1, the element there or the student record there is Moses and the course is backend. So we could just easily go here, output, run the put method on it. So if you're on a live project, it depends. If it is in production, you would want to turn off debug mode. If it is not in production and it's in a state we call staging, that's a test environment, even though it's live, you'd want to turn on debug mode so that when a user tells you that the application is failing and the likes, you can go to your test mode, replicate exactly what the user said they are doing in production, do it there and see the errors you get. That's a fast way of debugging it. Or you could even go one step ahead and create a login system. It sends all those debug messages straight to a cloud logger, and you can read it from there and filter easily. But that's a topic for another day. What will happen if we put with only one parameter? So let's try it and let's try that and find out. That's a nice question. So yeah, our server breaks because it is not designed to handle requests without a single without all the parameters. So it's sending a 400. It's telling us we're making a bad request because it's expecting 2 parameters and we are passing just 1. So it's broken, but you can put error handling in place for that and it would handle it. For the patch, we want to, let's update just the user 3. So we'll check later for user with ID 3. So the user with ID 3 is now going to be Moses Kunichi and staying full stack. And when we go to check the entire database, you would find that the ID of 5 has HR Chris. That was the user we added. The ID of 1 has switched to front end, and the person is called Wunichi now. And the ID of 3, which we just updated, is going to take full stack, and the name is now going to be Moses Wunichi, which we had just patched. So you realize that the ID, the name of the person, is going to be changed, but the course is going to remain the same. We are not changing the full entity. Yes, you can add something like a validation. Exactly. And you realize that in the patch. So we had an abort statement for when the index they put is out of bounds or doesn't exist. So let's put something like 8. We know we don't have up to 8 students. We run the 8. You realize that we are getting the 8 is being not found. So when Postman, you can change the presentation modes you want. So we can use a preview so we get it in HTML format. So we'll get the, you see, instead of it showing us 404, it understands what the 404 means and it's used the message itself, not found. And this is the message I passed in here for the abort statement, which is a student with a specified ID does not exist in our database. And you see each of the requests we are making is being logged here. This can be pushed into a cloud logger and you can run so many operations on it to get insights on how people use your website, which endpoints do they visit every time, because it would specify the endpoints. And you would also see, this is what I shared earlier, how the request looks like, an HTTP request. What response code did you get? So if maybe one of your sites, the URLs is down, there's an error there, it's always going to be 400, 400, 400, or 500, 500, 500. You can quickly go through your logs and know. You can even set a system to know that if maybe 10, 500 messages come from a certain endpoint, it should send you a message on WhatsApp or Slack and let you know. And all those can be designed. We actually use very, very interesting systems like that, and it's quite powerful. We can go to delete. So you pick which student should be removed from the class. and we would use that ID and remove the student. Okay, it seems like no one wants us to remove any students. We're almost done. Okay. Let me see. I would go with the number 4. The one you updated. Okay, that was, let's check. Let's check the one I updated. So I updated the first person, the whole object, and the third person, I updated just the name. And I also included at the ID of 5, I included the name Chris. So I think the last, okay, the one I just added. Okay, so that would be the ID of 5. So when I go to the delete method, I'll choose the ID of 5, then I send. So I just hit the send button, and it has already been configured to delete. I did this ahead of time so we can do things faster. And we go, it tells us, it gives us back the return of this. And you notice something, the city's code is 202 accepted. Okay, how do you create all the verbs at the left-hand side? The get, post, put. Okay, so with Postman, when you launch the application, by default, the tabs here gives you, it launches it. It's always going to be there. So it's not something I created. The application has that in the background, but you can do that manually from your code. You can generate your own push request, HTTP request. And that's with a package in Python we call request with S at the end. But with Postman, it makes it all convenient. You just click and it does it for you. So it makes work fast. So we can choose any of the methods. And when we try to run a different method on the link, you know, we specify that the endpoint receives only a delete here. But they are all using similar endpoints, so it might not work, but let's try this. You'd see that it says that method is not allowed for the requested URL because we've restricted it to just one HTTP verb, and that's the only one it would understand. The middle section, Okay, here. Okay, so this is just, I typed it in. So I use local host, which is the same as 127.0.0.1. That's your loop back. That's your local host. When you're running your server locally, you can either use the word localhost or you can use the IP 127.0.0.1, and that would work. Okay. Could you please clarify so I get your question? Okay. Let me change this while you're at it. I'll give you some time to type, and I am out of time, but I'll just run us through quickly with this. And please, the one below the import and new, if you could raise your hand and speak, that would help. That would help very much. Yeah, so please feel free to raise your hand so they unmute you and you can speak. Import and new. So here we are going to create a collection. So you're asking how I created these. So you can create a collection that would hold many requests which you can save and come back to Postman and use later. And you can go to the 3 dots here, which is the more icon. Click on that. No, forgive me. My mistake. It's rather the plus button. So we add a new collection and we go to the 3 dots to rename our collection mainly. It's still loading. Kindly give it a minute. Yes. So we go to rename our collection. I named it Top Universe, but you can name it what? Oh, let me use caps. Whatever name you like. And when you are done with that, and when you are done with this, you can click the drop down. But you realize that the drop down, there's nothing really there. So you can go here to the three dots here to the collection you have. So each project you have, it will be wise to organize it in groups of collections. You go to the three dots here, you choose add request. It will create a blank request here. You realize this is now a new tab. It's by default is on get. You've created a blank request. So here we want to go to localhost port 9000. We want to go to the slash route and we want it to be a get method. So we send a request and voila, we get the string we put in place for it to return whenever we go to the get endpoint. And that's how we create these. You can either duplicate this one to create a new one down here, or you can just add more. So you can go down and add another new request and it would add more requests for you. They are very interesting workflows you can go about using these collections. And that's a topic for another day, but there's a lot of things. Postman is a whole ecosystem on its own, and it's very powerful. If you have any more questions, please ask. I'll be moving on with this to where on the delete. So if we go to the get list, we view this, realize that the fifth entity, the one we deleted, is no longer in the list. And just to verify that it's actually deleted, we can go and try the first person. So maybe here we know currently we have 4 entities here. If we go to delete the first student, oh, we're still using the unlink, sorry. So we change it back to the delete verb. We go to delete and we see that it returns what we have deleted, so we know what we've deleted. The status code tells us it has accepted the request 202. And when we go back to view what's in the list, we realize that we are now down to only 3 students in our class. And that's just a rough overview of how these HTTP verbs work with RESTful APIs and using Postman to interact with them. You could also use Postman to interact with live APIs online. Okay, what we mean by statelessness of the REST APIs. So when you have a REST API, it's under the we're under the impression, or the REST is just a way of thinking. It's nothing specific. It's not like this is the rule or the likes. It's just a methodology. We are thinking in a certain way when we are working with RESTful APIs. So we design them according to that thought. We are designing RESTful APIs in a way that one request does not know of the other request, a previous request, another request that's currently ongoing, or a request that will be run later on. It's under the impression that it is the only request running and that nothing is for certain. An example of that is this student, these students list. We have a get request. When we run the get request, sure, we know that the JSON is there. The information is already there. Our database exists. But what this is going to do is going to check whether the database exists. If the database doesn't exist, it sends an error. If the database exists, it's now going to JSONify that data and bring it back to us. And that's statelessness. That means it doesn't know, keep track of state. Even though it's running right now, we all know that the database, if we send this request, is going to be there. The next time we hit this send button, it is still going to check whether that exists. When it is, if it finds out it exists, it's going to now convert it back to JSON and bring it back to us. It doesn't keep state. It doesn't keep knowledge or memory of what is in the system or what has happened to the system beforehand. And that's why when we run a post request, even though we created a user with this name and this course, we create it again, we have another user with that. Unless we now set checks and balances in place in our API, to handle that. Then we would have maybe some management, but it is statelessness. It doesn't have any knowledge of the state. When you go to delete, okay. It's just a typical example is usually delete. When you try deleting something from a database, say one, we've already deleted one. So we know in our list, we go here, we know there's nothing with the ID of one, but we try to delete one. Instead of it to know, because it was this same endpoint we used to delete the one, it is still going to try deleting it. Then it will now realize, oh, the user doesn't exist. Then it will send an error, which was the abort statement we used earlier in the code base. So if we didn't put this abort statement in for the delete operation, it would have sent a different error altogether. And that's it being stateless. It has no memory or no knowledge of what is happening. So the last thing I'll just take us through is the request online API. So there are a number of online APIs we can use. And an example is a request response site. You can hit their live, they have live APIs there. So when you just visit the site, you get their APIs, you get their endpoints, and you can make requests to it and get live response and make actually make changes on it. So you can go here, go to their site, get so when you click on this, it will give you a sample response. This is how it looks like. But you can just copy the URL they have and work on it on yourself, like by yourself, and see how you get that. So let's see this. Okay, it's taking a while to load. I wonder what's going on. Probably the network. But just ignoring that. So I have copied the URL, which is HTTPS, that it uses a secure socket layer SSL. That's why the S exists here. That's just to encrypt the information we are passing and we are receiving, and also returning to them. That way, if anyone intercepts it, they are going to see that information as gibberish. So the name and the course and the ID we're passing, if it was within an HTTPS route, it would have been encrypted. And if anyone intercepts it, they can't do any meaningful harm with it. And we are hitting their host, which is the recres.in, in. Then the URL is /API/users. And this is the query parameters I was speaking about. The get request is to retrieve information for the client. So you make a request, you type the endpoint, the URL in your browser, it retrieves some information from the database, gives it to you. But at the same time, get request can also take information from you. And that's what we call URL params. And an example of it is this. We use a question mark to denote that we are beginning to specify a URL parameter. And then we put the name of the URL parameter, an equal to sign, and the value for the parameter. And if you want to chain more query params, you just use the ampersand, and you add the next parameter. Maybe the next parameter is called name equal to Moses, and you send a request. But seeing at this API, I don't know whether it has things to handle it, but yeah, it just ignores it. So these are ways of working with APIs online. I'll be ending soon, but I just wanted you to know that you can access live APIs right now online and use Postman as a means to interact with that API, get information from it, make different kinds of requests to it, and get the response you should be expecting. And this one is well documented. They have all the endpoints. They give you sample response here, so you know what you are expecting. This down here is the status code. They give you the status code in case of a success. So mostly they only state the success ones. They don't state the failure status codes. And they give you the API route, not the host. So the host is just HTTPS this. Then you attach any of the API routes you like to it. Yes. So that was a brief talk, maybe a bit too brief, that was quite long, on RESTful API HTTP verbs and using Postman to work on them. My name is Moses Munichi, and it was nice talking to you all. If you have any more questions, kindly ask them. So I try to answer them to the best of my capacity. Yes, I like very interactive um, sessions. It reduces the tension really. Thank you very much as well. Any questions? Any questions? Okay, so in the absence of questions, yes, so is Amaka here or Emanuela would take over then, I think, because she's the host. Hello, if you're speaking, I can't hear you.
Okay, hello Moses, I'm still here.
Okay, okay.
All right.
So yes, I think that ends my talk on HTTP verbs.
Okay.
It
All
was
right.
really nice having you.
I think they also enjoyed this session. So you guys can say thank you to Moses for having a wonderful class. I think he answered most of your question and he did well. Moses, thank you so much for coming on this call. It was nice having you.
We are welcome. It was a pleasure as well.
All right. So, all right, guys, that is all for Moses and us. If you still have questions, you can drop it on the Discord room. Will be answered later on. Until then, good night. You can also tweet and follow as well as post. I will drop this LinkedIn handle so you can follow him or send a connect on Twitter and LinkedIn, respectively. So, good night, Moses. Thank you once again. Good night, everybody.
Okay, have a great day. Bye.
Okay, bye.